This is Grape Video 41, Vineyard Site Selection, Part 3, The Valley. In Grape Video 39, we talked about a global or worldwide view of vineyards and why they're located where they are. And then in Grape Video 40, we looked at localized situations and explained why topography is the dominant physical factor influencing the location of vineyards within a particular viticultural region. In that video 40, we illustrated thermodynamic principles that were involved with topography, but we never gave any specific examples of how this actually works with real temperatures. So this video is going to go into great detail on a study that we did for 11 years in this small valley in southwest Michigan. Here's a picture of that same hillside in the wintertime. We collected temperature data 24 hours a day for 11 years at many locations throughout this valley, and 9 in particular. And we collected over 1 million data points of information. And we're going to show you the summary of those data and illustrate how topography has influenced the decision of where to plant and where not to plant a vineyard in this small valley. We did that temperature data collection with gadgets like this. This has within it a device that is programmed to collect the temperature every hour of every day, and we change that device out every 6 months. And this white gadget is called the radiation shield, so it does not get the influence of direct sunlight on the temperatures being recorded, but it's always a shaded temperature. Now, if you're wanting to do some temperature recording of your own, you don't have to be this sophisticated. You can do it more simply. Here is the type of thermometer that we used years ago. It records maximum and minimum temperatures, and you might be able to see in the two tubes that there are long blue magnets that are pushed up as the mercury in this thermometer rises, and those magnets do not come back down until you reset them with a magnet. So we have a measure of the maximum and minimum temperatures recorded by this particular thermometer, and they cost about $20. We put them within a shaded box such as you see here, and those have been very useful over the years. Not quite as sophisticated as the electronic gadgets, but still very useful at times to understand the minimum temperatures, especially in a particular location. And you might want to do that if you have some property that you want to learn something about the thermodynamics of that particular parcel. And here it is. This is a schematic of the valley we're going to be talking about. And along this pink or magenta line, there are 9 locations that we're going to talk about in detail. The highest point is at 776 feet above sea level, or 235 meters. The lowest point is at 717 feet, or 207 meters. That's a total range of elevation of 59 feet, or 18 meters. That's all. 59 feet or 18 meters total difference in elevation in these 9 points. Well, that is about 140 feet higher at the bottom of this valley than Lake Michigan. That we've shown you this picture of the Lake Michigan shoreline. That's about 12 miles away. So over a period of 12 miles or 19 kilometers, the elevation drops an additional 140 feet or 43 meters, and water from streams in this small valley would go into Lake Michigan. As far as distance, horizontal distance across this valley, we're really only talking about 2,250 feet or 4/10 of a mile, or about 682 meters or 0.7 kilometers from location 1 through location 9 on the right. That's all. And just for point of reference, that star on this map shows you exactly where this little valley is. It's in the very southwest corner of the state of Michigan and 12 miles from that shoreline of Lake Michigan, as we just pointed out. Well, as we have the 9 locations where we collected data plotted on this graph, it really does look like a somewhat impressive valley. But if you look closely, on the left side, or what mathematicians would call the ordinate, we only have a distance of around 100 feet from top to bottom of that scale, as opposed to along the bottom, or the abscissa for you mathematicians, we have 2,500 feet. So we've plotted this at 2 different scales to give the impression of the valley that occurs here. If we plotted both the ordinate and the abscissa at the same scale, it would look like this. Yikes. Not much of an impressive valley at all. But we will show you with video and a drive through the valley that it truly is a valley, but it is a very modest topography indeed. So as we begin this presentation, we fully admit this is a non-traditional approach to discussing the topic of vineyard site selection, and we certainly are not trying to make you aware of the details of this particular property. No, our goal is different than that. Our goal is to answer this question: how do the thermodynamics of this valley relate to property that you might purchase or already have purchased for a vineyard? So keeping that goal in mind, let's begin. Let's go back to this scale of the schematic for the valley, and we're now going to take time to go through each of the 9 locations and where they're located, because when we get to the data, we want you to have a mental picture of each of these 9 locations. So that red dot is location 1, and it is at the high point of our transect through the valley. And what we're going to do then is go through this step by step from one location to the next. Well, here is location 1. It's located at the north end of a vineyard that has rows about 500 feet long. So we're going to take you on a ride down that vineyard row. Before we do that, I want to show you a picture of this vineyard at harvest, because as we take the video tour, you're going to see vines that are quite tall. I have trellises 8 feet tall, and the vines extend a foot above that, so about 9 feet of trellis, and it'll look kind of hairy in terms of the canopy, but at harvest it looks much more organized with 2 fruiting zones, 2 fruiting wares, upper and lower fruiting wares as seen here. So let's take that ride down that row. And we're going to go on that yellow line. We're going to drop 3 feet in elevation as we take this ride down the row. Here we go. Well, here we are on our first segment of our trip across the valley, and we're speeding this video up 4 times normal so it won't take as long to see this. And we're going about halfway down that long row to the second location right here, location 2. And you may have noticed that there wasn't much of a drop in elevation, just 3 feet in the 252 feet we quickly traveled. So here we are at location 2, and you may wonder why I have 2 radiation shields at this location. It is because twice a year we swap out the recording sensors, and over the years we've acquired different size sensors that require different size radiation shields. So that's the explanation. Anyway, we're in the Cabernet Franc vineyard, about 2/3 of the way to the south of the long row, and we're going to take a look at where we're going to travel next. It's going to be a drop in elevation of about 21 feet or 6 meters, and we're going to travel out of the Cabernet Franc row and across this open area that we like to call the party area, because we've had some really lovely parties up in this area. As we turn around and look back to the Cabernet Franc as they're ripening, we look back up the row where location 2 is, and it's about 100 feet or so up that row. Where we're going to wind up is 1/3 of the way down the steep terraces, as we call them, south-facing rows with Cab Sauvignon on them here very late in the season on a November day. So we're going to start down a steep slope after we go through the party area. So now let's take that ride. Here we are, starting at location 2, and we go out the row of Cab Franc about another 100 feet, then zoom across the party area, start down the steep slope about 1/3 of the way, and go out on Terrace 4. And there's the next sensor. Sorry for being so shaky, and we're looking briefly down into the valley. That was a trip of about 398 feet or 121 meters. So looking at location 3, we can see down into the valley. In this particular year, there is corn being grown in the valley bottom. And we're going to travel another 4 terraces, or another 1/3 of the way down the steep terraced area, but we're only going to drop 13 feet in elevation or 4 meters. So here we go with that. There is location 3. Sorry for the jerky ride. We go out Terrace 4, make a turn, go down a few feet, and then back out Terrace 8. There are 12 of them altogether. And now we see this recording device, and we're looking down into the valley. We have traveled a distance of 59 feet and dropped 13 feet in elevation. So here we are at location 4, 2/3 of the way down the steep slope of the terraces, as we call them, and we're headed for our next location. The red arrow indicates it. It's location 5. It's right in the corner of where that field corn is being grown, and you're going to see that very shortly. And we're going to drop 22 feet in elevation or 7 meters. And here goes the ride. Down Here we're in the valley bottom now. Corn is on our left. Going around the corner and right down where the corner of the corn field is, we find location 5. And it's fairly close to the flagpole, as you can see here. So we traveled 347 feet in that trip, and we came down to the lowest part of the valley right now. It's at 717 feet of elevation. There's a picture at location 5. We're now going to travel past the flagpole over to that utility pole right there, and right at the base of that utility pole is location 6. It's about 5 feet higher in elevation there. Just a gentle climb starting back out on the other side of this small valley. It's going to look like that. 5 feet up, and we're not going to travel very far. So here we are at location 5, headed for location 6. Going past the flagpole, over to the base of that utility pole, and you can already see the white radiation shield at the base. There it is. There it is. And as we turn, we look back up the steep south slope where locations 3 and 4 are located. We've just traveled 212 feet or 65 meters. And there is location 4, one of the sensors we just looked from down into the valley, and we're looking back at it now. If you see that little white dot in the middle of the red circle. And now we're looking back from location 6 downhill about 5 feet of elevation, and there over in the corner of the cornfield is location 5. All of this for reference. Okay, we continue our journey across the valley, and this time we're going to travel up 15 feet in elevation or 5 meters, and we're going to travel up the slope on the other side of the valley. Here we go. Get out of our pine tree planting and travel up the driveway across the road that's in the bottom of the valley, turn in, and on this side there's a golden delicious apple orchard, and we are now arriving right here at location 7. And looking back, there we are in the distance at the south slope that we were looking at locations 3 and 4. And as we slow down the movement here, you can see some golden delicious apples on these trees. We traveled 347 feet in that trip. And here we are. This is a better picture showing the apple trees. Now we're going to travel up another 22 feet of elevation to go to location 8. Here's location 7, getting ready to travel. And we continue up through the golden delicious orchard, and we get to some vineyard. This vineyard has been abandoned for 2 years, and we'll talk about that more eventually. But down one of the rows on a post here in this abandoned vineyard is location 8, right there, right there. We just traveled 262 feet or 80 meters as we came up the hill. And there we are. It's a sad looking state of affairs here in this Merlot vineyard that hasn't been worked in 2 years, and I can see powdery mildew on some leaves there, and there's also signs of downy mildew. Some fruit that happens to be there ripening, but it's only going to serve for bird food. We're not working this vineyard anymore. So we'll make the last leg of the journey across the valley. We're just going to go up in elevation about 2 feet or 1 meter and go into a larger vineyard. Let's make the trip. There you go. Out of this abandoned vineyard, up a gentle slope, turn down the headland, and then we're going to go out one of the rows on our right, and as we do, we're going to dip down to show you some heavy ground. We'll talk more about that later. And we get out here a little ways, and on one of the line posts right here is our last location, location 9. And as we pan around, we see this very sad looking abandoned Merlot vineyard. And we'll talk more about that. We just traveled 324 feet or 99 meters. Well, here we are at location 9, the most southerly location for our temperature sensors in this transect across the valley. And you can see this very nasty abandoned Merlot vineyard. This vineyard is about 8 years old, and we're going to talk more about why this vineyard was abandoned, why it did not perform well in this video and in another video. So there we have it, our quick trip across a small valley in southwest Michigan. And to summarize that trip, we had a total range of elevation difference of 59 feet or 18 meters. And the distances that we traveled through that entire trip were about 2,250 feet. That's about 4/10 of a mile, or 682 meters, or about 7/10 of a kilometer. That's it. And now we're going to look at the study we did for 11 years to analyze the 1 million plus data points that we collected on this valley in southwest Michigan. We now present a mesoclimate study of a southwest Michigan valley. And before we go any further, the reason we're doing this is to give you some concepts and some principles that you might follow to do some vineyard site selection on your own. It may be that you're going out to work with a realtor to find property in a viticultural region. It may be that you already own property and you're trying to decide what parts of that property are suitable for a vineyard. The information that we will present here will give you insights on how to go about that process. I hope you'll find it useful to your viticultural pursuits. So what did we do? We took hourly temperatures, and they were recorded at the 9 locations we just showed you for the 11-year period from 2005 to 2016. Collectively, we gathered over 1 million hourly temperature data points. And what these temperature data tell us about the suitability of these 9 locations is the point that we're trying to make here. And we will go into that in so much detail that you will get a real feel for how this land, this small valley, varies so very much in its suitability for a vineyard. Let's begin. We thank Jenny Schoonmaker for the extensive work that she did to tabulate and summarize all of the many data that were collected over 11 years in this study. so that we could present them to you. Well, the first thing we need to say about the suitability of a vineyard is that the number one issue in a cool climate vineyard is winter injury. If the vines don't survive through a winter, if they die completely, or if they're killed back, such as these Riesling vines in the Traverse City, Michigan area, we had these vines killed, as we say, to the ground, so to speak. And the only reason that we have all this sucker growth coming up from the ground is that we had 16 inches of snow, and that buried those buds near the ground in protective snow cover, or we'd have lost the vines completely. If you severely injure or outright kill vines, nothing else matters. Nothing else matters with the rest of the growing season and growing degree days and the length of the season and so on. Doesn't matter if you can't get the vines through the winter when you're growing vines in a cool climate. So we're going to deal with winter low temperatures as a first priority in this presentation. And as a review, in video 39, we said for the varieties we're growing in Michigan, these are the temperatures that we consider to be problematic, that we start to get concerned about winter minimum temperatures when the temperatures go below 0 Fahrenheit or minus 18 Celsius. And then for these increments, as we continue to go lower and lower, we start to get modest injury, moderate injury, severe injury. And of course I'm generalizing because it really depends a lot on the varieties you're growing and how hardy they are. So we're generalizing across all the varieties we grow. But if we have a winter that starts having minus 10 to minus 15 Fahrenheit or minus 23 to minus 26 Celsius, we're concerned. We're very concerned. So let's see what the temperature data we collected in this valley look like relative to this temperature regime that we're showing right here. Now, we're not saying that this table of winter minimum temperature benchmarks is applicable to all viticultural regions worldwide. In fact, it is not. So you will have to determine whether this applies to you and the varieties that you intend to grow in the viticultural region where you are trying to select a vineyard site, or whether you need to apply your thinking to a different table of data similar to this. Okay, we're finally ready to show you the data from the Southwest Michigan Valley that we've been talking about, and we're going to begin with the 11-year average winter minimum temperatures for those 9 locations we've been showing you. And we're going to start by looking at 5 locations that we've circled in yellow. We're going to look at the first 2 locations are these that were in the long rows of Cabernet Franc where we began our travel. Then we come down to those terraced areas, locations 3 and 4, right here. And then the 5th location is the location on the south side of the valley where we saw the Golden Delicious apple orchard midway up the slope. And if you look at all 5 of those locations, on an 11-year average, the winter minimum temperature was minus 3 to minus 5. So now let's relate those winter minimum temperatures to this table of winter minimum temperature benchmarks. And at minus 3 to minus 5, they fall in that range that says we're getting concerned, we may have some modest injury. But that's pretty decent, all things considered. By the way, we're going to just talk in Fahrenheit, but for those of you who live in the Celsius world, it is presented on all of the charts that we present here. So you can just look at those numbers while we talk Fahrenheit and get a reference for Celsius temperatures. But it'll be too confusing to go back and forth and back and forth. So on average, over the 11 years, for those locations that we just showed you, those 5 locations, this is pretty decent. We have only getting concerned to modest injury values for those average minimum temperatures during the winter for 11 years. Okay, now let's look at the other 4 locations and the 11-year average winter minimum temperature for those locations. Let's start in the valley bottom. These are the 2 sites in the vicinity of the flagpole, if you'll recall. And look at that, -10 on average for 11 years. Ouch, that's a pretty low number, and it really gives explanation about the low part of the valley not being very suitable for a vineyard. -10 year in and year out in these 2 locations in the low spots of the valley. Well, if we look at the 2 locations up on the south side of the valley, the last 2 locations we looked at, the 2 locations in the abandoned vineyard that we're going to talk more about, wow, -10 for location 8 and -7 in location 9. That's surprising to me. I didn't think up on that side of the valley that we would have such low average minimum temperatures for an 11-year period. They're almost as bad as down in the valley bottom. Well, we now have an explanation for that, which we'll get to in a little bit. But those 4 locations, circled in yellow now, begin to make us say, wow, this is not such a good place for a vineyard. And when we relate it to our table of winter minimum temperature benchmarks, those -7 to -10 values on average translate to modest to moderate injury year in and year out across this 11-year period. Not good, not good. Well, now we're going to look at the 11-year lowest winter minimum temperature that occurred in each of these 9 locations at any time during that 11-year period. What was the absolute lowest winter minimum temperature? Well, we're going to start out by looking at the 3 locations on the mid-slopes. That's the area of the terraces, locations 3 and 4, and the location of the Golden Delicious orchard on the other side of the valley. And the lowest temperature we recorded over 11 years in that location was -12. Well, that puts us, according to our benchmark values here, in a moderate to severe category between -10 and -15 Fahrenheit. That's concern, but actually, if we only have that happening to -12 in one time out of 11 years, that's actually survivable. So we have that mid-slope location with a lot of topographic fall on both sides of the valley. That's what we can expect. Okay, now we're going to look at some of the locations up towards the top of this valley. These three in particular. Look at that. Minus 14, minus 13. Remember, that's the long rows of Cabernet Franc. And over here, minus 15. That's the first location of the abandoned Merlot vineyard that we looked at. Those numbers are low enough that I'm going to put those into a new category all by itself that we're going to say is outright severe injury. And in reality, that is what happened in those locations. Those long rows of Cabernet Franc that we showed you actually got severely winter injured about 3 years ago, and we undertook a massive trunk renewal program and put all new trunks on those vines. We didn't kill the vines, but we did injure them so severely in the winter about 3 winters ago that the minus 15 or temperatures close to that actually did cause severe injury, and we were fortunate enough that we could renew those vines, and we now have productive vineyards again. Okay, now let's look at 3 other locations, and we're going to start with those in the bottom of the valley, near the flagpole, if you will. And wow, minus 18, minus 21. Our varieties that we traditionally grow in southwest Michigan do not survive those temperatures well at all. I mean, they will have extensive damage, severe injury to vines at a minimum. Then, up on top, the last location, the abandoned vineyard, if you will, location 9, minus 17. I really didn't expect that from that location. I thought, wow, this should be draining some air. We shouldn't get such precipitously low temperatures at that location. But we did. We did. So I'm going to put those in a new category of this temperature benchmarks table. I'm going to call that catastrophic, because temperatures that low, minus 17 to minus 21, are likely to outright kill vines of the kinds that we grow, unless the low temperature occurs when we have abundant snow cover. But still, the temperature itself is catastrophic when we have something that low, and that points out how poor the choice would be to put a vineyard in that valley bottom of this particular small valley in southwest Michigan. Well, I think it's time to start giving some explanation why the location at the south end of this valley is such a poor choice for a vineyard. Why did it have a minus 17 degrees Fahrenheit low winter temperature for that 11-year period? Why did it become an abandoned vineyard? There's a couple of reasons, but we're going to give one of them right now, and it's this. If we look at that transect through the valley and its 9 locations, when I first began the study back in '05, there was no vineyard here. It was an open field, and I put a stake in the ground and put the temperature recording device 5 feet above ground, as is the standard procedure. And it was 3, 4, 5 years later that the owner of this property decided to put in a vineyard. And that vineyard has been there for 7 years or so and has now been abandoned. Well, what I didn't realize at the time when I started this study was that there's more to the story, and here's what it is. Turns out that in the direction you're looking at with this picture now, that property actually extends much farther to the south as a very, very flat piece of ground. It doesn't have any topographic relief whatsoever. And then to make it worse, the property beyond that slopes upward. And so location 9 that you're looking at now, that would look like it was an air exporting site if we just looked at the transect and the 9 locations that we looked at. When we look at the bigger picture, all of the cold air from this property, and it's a large piece of property, actually drains down into this flat area right here, and this actually becomes an air importing location right here. Right up here, what you're looking at is actually flat ground, and way out beyond this is higher ground, and that allows air to come in. And so here we are at the top of the valley on the one side, and we have these low temperatures brought on because of this topographic relief. That was a learning experience for me. I hadn't looked at the property beyond location 9 to understand that. So amazing. Here we are at the top edge of this valley we're looking at, and it's an actually air importing location, leading to low temperatures in the winter that can be as low as the valley bottom, as you've seen. So here is one of the take-home messages from this video. When you are considering a vineyard site, be it property you have bought or property you're thinking of buying, be sure you check the airflow as influenced by topography in all directions from that site. As we stand here looking down this slope, it would seem that this is a suitable vineyard site. And indeed, the vines in front of us probably could be renovated from winter injury and be relatively productive. But when we turn around and look 180 degrees the other way towards the south, we see this. We see a large vineyard on a very flat surface that has at the end of it orchards that are even on higher ground that drain cold air from those orchards down into this flat area. And ironically, this location is a cold air importing site and resulted in quite low winter minimum temperatures that ultimately caused this vineyard to be abandoned. Well, you might think this is the end of the story and that the influence of the topography in this valley in southwest Michigan is on the winter minimum temperatures, and that's that. Not so. Remember back in Grape video 40, just the previous video, we said that cool climate viticulture is where there is inadequate heat. And we said that that occurs not just in winter, but in spring and in summer and in the fall. And so we're going to look at how the data we collected in this valley influences those other seasons too. And we start with the length of the growing season, from the last freeze in the spring to the first freeze in the fall. And as we go across this valley, we can see that as an 11-year average, these locations 1, 2, and 3 on the north side of the valley that we looked at first in our travelogue across the valley have, on average, for 11 years, about 169 to 175 days in the growing season. That's pretty decent. That's pretty decent. However, when we look at these 4 sites, we've come down a peg. We've come down to growing seasons that average 159 to 162, or a couple weeks or so less than the first 3 sites that we talked about. And then when we get to the bottom, oh my gosh, when we get down in the valley near the flagpole, the average length of the growing season there for those 2 locations is only 150 to 157 days. So if we take a look right here, here we have 175 days, down here 150, a 25-day difference, or almost a month on average difference in the length of the growing season, and that's directly related to the topography of this valley. Wow. Well, now let's look at the shortest growing season in the 11-year period. And if we look at those better sites on the north side of the valley, facing south, 156 to 162 days, that's a challenge to ripen a crop decently with a growing season that's getting that short, but fortunately this was the shortest growing season in that 11-year period. Well, then it gets progressively worse. Here we have a couple of sites, 140, 142 day growing season. This location down on the terraces, south facing, but getting low towards the valley bottom, is subject to spring and fall freezes a little later in the spring, earlier in the fall, because as the valley fills up with cold air, this site is getting down towards that valley bottom. This site over here is on the north facing cooler slope, and so it too becomes subject to a shorter growing season than the better sites that are facing south. And then when we look at these 4 locations, 136 to 137 days in the growing season, the shortest growing season, we talked at length about how this location number 9 is actually importing cold air from further to the south here, and it's coming in and having spring and fall freezes that shorten the season. And then just like this location here getting down towards the bottom of the valley, this one too, and here we are in the bottom of the valley. So 136 days of growing season. Wow, that really doesn't make for maturing a crop. You'd better have a very short season, early maturing variety there if you're going to have any chance whatsoever. Okay, now we're going to look at average growing degree days, not the length of the growing season, but how much heat that we are accumulating during the growing season. And the typical way to express this is for the time period April 1 to October 31, that is when we're in the northern hemisphere. And so collecting data and analyzing in this way, we can say that the locations that are up and away from the valley bottom were slightly better than those a little bit lower. These locations had slightly less growing degree days, but in general, all of these are so similar. If you were collecting information and analyzing growing degree days for locations based on an April 1 to October 31 formula, as is typical, you really wouldn't learn much of anything different about these 9 locations. There's very little difference. So, we'll look at that April 1 to October 31 time period for the year with the fewest growing degree days before we move on. And once again, these sites on the north side of the valley facing south have a somewhat higher growing degree day accumulation than perhaps over here or here. But the truth is, in 2009, there was a general advective freeze. That means that it wasn't a matter of topography, it was a matter of a big cold air mass coming down from the Arctic that caused a very short growing season, and virtually all of these numbers are for that year 2009. So they really aren't influenced by topography as much as a single event that occurred in 2009 with a massive freeze of an air mass coming down from the Arctic. Well, it seems to me that the only growing degree day information that's really pertinent, that's useful to analyzing how the vines will function, are those growing degree days, that heat that occurs when the plant is alive and healthy. If it is killed in the spring and then regrows, or if it is killed early in the fall, whenever the plant is already injured in the spring or in the fall, those growing degree day units are pretty much meaningless, aren't they? So what we did here is to look at the 9 locations, and we put them in perspective to the growing degree days as they occurred from the last spring freeze in the spring to the first fall freeze, and those are the numbers in white. And then in parentheses next to it, we put the growing degree days for the more traditional April 1 to October 31 information. And here we have 2,800 plus growing degree days still from freeze to freeze on the more intermediate quality sites. That growing degree day accumulation starts to slip, and as we get to the more inferior sites, once again remember that this is actually an air importing site, and here we are on the north facing slope, and here we are in the valley bottom, and all of those have much lower growing degree day accumulations from freeze to freeze than the more superior sites on the north side of the valley. Well, because we had the 2 types of growing degree day data, that is data from April 1 to October 31, and also the data from the last freeze in the spring to the first freeze in the fall, we calculated how many growing degree days we lost due to the freezes in the spring and fall. And here's what it looks like. On the north side of the valley, facing south if you will, we lost as little as 147 growing degree days due to those freeze issues, and as much as 252 high on the south facing terraces. When we got to the other side of the valley, that is the south side of the valley but facing north, we began to lose more growing degree days due to freezes, and it approached, but not quite, getting towards 300 growing degree day units that we lost due to freezes in the spring and fall. As we get low on the terraces here towards the valley bottom, and in the valley bottom, those two locations near the flagpole, we lost over 300 growing degree day units due to the freezes in spring and fall. And the very bottom of the valley, this lowest spot, approached not quite 400 units of growing degree day temperature during the growing season that we lost due to spring and fall freezes that occurred after April 1 and before October 31. Okay then, to finish up the growing degree day story, if we take the lowest growing degree day accumulation in any year of the 11 years, the coolest year still had on this north side of the valley about 2,600 units, and that is adequate to ripen a crop, if not ideally, at least fair. And just slightly less satisfactory as we go down that south-facing slope on the terraces. Things start to slide even more on the south side of the valley that is facing north, and when we get to the valley bottom, 2,200 plus growing degree days, and that is really going to challenge many varieties. Even if they survive there, even if they produce a crop and aren't frozen out, that's going to challenge us to ripen many of the varieties that we grow well with 2,200 growing degree days. So that points out the inferiority of these sites in the valley bottom. Okay, we're almost done with this video, and I appreciate your patience. It's been a long one, but a couple of side trips before we finish. I thought I would contrast just two of the locations. Location 3 here, that is up high on the south-facing terraces, and location 5 in the very bottom of the valley. And we used very precise GPS technology to measure the distances and elevations. So it is 406 feet or 124 meters between these two locations, and the elevation difference is 35 feet or 11 meters. So if we look at just these two, look at this. The average winter minimum temperature was -3 for location 3, where we are standing taking this picture, and -10 down in the valley bottom. The 11-year winter minimum, all-time winter minimum, -12 where we're standing, -21 down in the valley bottom. The average growing season, 169 days where we're standing, 150 days down in the valley bottom, 406 feet away. And if we take the very shortest growing season, 150 days where we're standing, 136 days down in the valley bottom. And the average growing degree days, 3,038, 2913. Remember, I told you that the average growing degree days as measured from April 1 to October 31 is a very insensitive measure because it arbitrarily collects data for those several months without taking into account freezes in the spring and fall. So those numbers aren't so very different. And that's what's scary about using that kind of information. And if we have the shortest growing season accumulation by that caliber, April 1 to October 31, once again, the differences are very small. But if we take a growing degree day measurement from spring freeze to fall freeze, you can see there's quite a difference between those two sites. And if we take the shortest growing season from spring freeze to fall freeze, very similarly, about 340 growing degree days difference. So I implore you, when you look at property, to look it over carefully. The real issue here is, as we said in previous videos, do the locations that you are considering for a vineyard export cold air, or do they import cold air? And you could see by these numbers that it really, really, really makes a difference. Well, what we haven't told you up to now, that we actually had other sensors out recording hourly data, in addition to the 9 we've been talking about at great length. Well, we erected these poles, and this is a 30-foot tall pole, and we put sensors every 10 feet. We actually had one right at the base of the pole at the ground level at 10 feet, 20 feet, and 30 feet. Then we had other poles that were 20 feet tall and 10 feet tall, and we had sensors at 10-foot intervals on those, so that we had sensors that were horizontally the same across that line, say, and then like this and like this. And we had some very interesting experiences over the 11 years recording some of the thermodynamics of airflow on this hillside. Let's show you some of that. All right, here are some temperatures that we recorded on April 26, 2006. They were recorded at 4 a.m. in the morning. And we'll start with the 30-foot pole right here. And as we've talked so many times about cold, dense air, the colder, the denser it sits at the ground. As it's a little warmer, it's lighter, goes up more and more up the pole, 24, 26, 30. A nice temperature inversion on a radiation freeze as shown on this 30-foot pole. We also see that the air along the ground, be it 23 right here, 22, 22, this is the coldest air, the densest air, and that verifies our discussion of cold, dense air flowing along the ground. If we look at the temperatures in those horizontal planes, we can see 28, 28, and 30, 23, 25, 26, similar temperatures in that horizontal plane. And then similarly, 22, 24 in that lowest horizontal plane. Interestingly, when you have these horizontal planes, the temperature does get slightly warmer the further away you get from the surface of the soil. So this temperature out here in this plane is 30 degrees, is warmer than the other two. This 26 degrees is slightly warmer than those closer to the soil surface. This 24 degree temperature, somewhat warmer than the 22 degree temperature at the same horizontal level. By the way, the temperature sensor in the cab franc rows, which would be our location 2, at this very same time at 4 in the morning was at 31. Warmer, and importantly warmer than all of these temperatures down low on the terraces as we approach the valley bottom. How important is topography to critical temperatures during a spring freeze? Very important. Lastly, here we are in the valley bottom location, number 5, and of all the million data points that we took, you would think that someone would have sense enough not to plant grapevines in this low spot in the valley where the winter minimum temperatures are the worst, the growing degree days are the worst, the growing season length is the worst, and so, yeah, here are some grapevines. Turns out they are bordering a driveway, and I've planted these. They're not just any variety. They're one of the University of Minnesota super hardy hybrids. This is the Marquette variety. And we're going to just see if, even with these challenging temperatures down in the valley bottom, whether or not we can make these vines survive, and in some years at least, produce fruit. The blessing of this variety is not only its hardiness to minus 36 Fahrenheit, the University of Minnesota suggests, but that it ripens early. So we can possibly ripen this fruit if we can get the vines through the winter, through the spring freezes. We thought we would just give it a try. Well, that's all for now. This isn't the end of the story of site selection, by the way. We're going to talk about other factors. Topography is the most important factor, but there are other factors such as soil. And we're going to talk about that in upcoming videos. But for now, we thank you for your attention. And as always, happy grape growing.